Rather than focusing on the methods and processes behind the creation of a GE crop to determine if testing is needed, a more effective framework would examine the specific new characteristics of the crop itself by using so-called omics approaches, the article asserts. In the same way that biomedical sciences can use genomic approaches to scan human genomes for problematic mutations, genomics can be used to scan new crop varieties for unexpected DNA changes. These measurements of thousands of molecular traits can be used like a fingerprint to determine whether the product from a new variety is substantially equivalent to products already being produced by existing varieties. Whether, for example, a new peach variety has molecular characteristics that, if the new product has either no differences or understood differences with no expected health or environmental effects when compared with products of existing varieties, no safety testing would be recommended, the article suggests. If, however, the product has new characteristics that have the potential for health or environmental effects, or if the product has differences that cannot be interpreted, safety testing would be recommended. The approaches used right now, which differ among governments, lack scientific rigor, said Fred Gould, University Distinguished Professor at North Carolina State University, co-director of NC State's Genetic Engineering and Society Center and the corresponding author of the article. The size of the change made to a product and the origin of the DNA have little relationship with the results of that change. Changing one base pair of DNA in a crop with 2.5 billion base pairs, like corn, can make a substantial difference when dealing with varieties made using the powerful gene. Meanwhile, in 2020 the U.S. Department of Agriculture established a rule that exempts from regulation conventionally bred crop varieties and GE crop varieties that could have been developed by methods other than genetic engineering. The most important question is, does the new variety have unfamiliar characteristics, Gould said. The paper estimates that technological advances could make the laboratory cost for a set of omics tests decrease to about $5,000 within 5 to 10 years. Establishing an international committee composed of crop breeders, chemists and molecular biologists to establish the options and costs of omics approaches for a variety of crops would start the process of developing this new regulatory framework. Workshops with these experts as well as sociologists, policymakers, regulators and representatives of the general public would enable trustworthy deliberations that could avoid some of the problems encountered when GE rolled out in the 1990s. National and international governing bodies should sponsor these committees and workshops as well as innovative research to get the ball rolling and ensure that assessments are accessible and accurate, Gould said. Make a difference. Sponsored Opportunity Story Source. Materials provided by North Carolina State University. Original written by Mick Kulikowski. Note: content may be edited for style and length. Researchers propose new framework for regulating engineered crops. Science Daily, the 1st of September 2022. ift.tt/jarv9thai. North Carolina State University. 2022, September 1. Researchers propose new framework for regulating engineered crops. Science Daily. Retrieved September 1, 2022 from ift.tt/jarv9thai North Carolina State University. Researchers propose new framework for regulating engineered crops. Science Daily. ift.tt/jarv9thai. Accessed September 1, 2022. Thanks for watching. Please subscribe my channel for more videos.